Heat and mass transfer are two closely related phenomena that describe the movement of energy and matter, respectively, from one place to another. Heat transfer refers to the transfer of thermal energy from one object or substance to another due to a temperature difference between them. The three main forms of heat transfer are 1. Conduction. Heat transfer through a material by the transfer of kinetic energy between adjacent molecule or atoms. 2. Convection. Heat transfer through a fluid such as air or water due to the motion of the fluid itself, which can be caused by natural or forced means. And 3. Radiation. Heat transfer through electromagnetic waves which can occur in a vacuum and do not require a medium. Mass transfer, on the other hand, refers to the movement of matter such as molecules or particles from one location to another. Although there are multiple forms of heat and mass transfer, we will only be focusing on convection. Heat and mass transfer are important in many fields, including engineering, physics, and chemistry. Understanding these processes is crucial for designing efficient and effective systems for heat and mass transfer, such as heat exchangers, refrigeration systems, and distillation columns. Now, although there are commonly three main forms of heat transfer, I am going to mainly discuss on the concepts and theories behind convection. Convection is the transfer of heat through the movement of fluids such as liquids or gases due to a temperature difference. This movement of fluids is called convection currents. There are two types of convection: natural convection and forced convection. Natural convection occurs when a fluid such as air or water is heated from below, causing it to become less dense and rise. This creates a convective current that pulls in a cooler liquid to replace the rising fluid. The cooler fluid then heats up and rises, continuing the cycle. Forced convection occurs when a fluid is forced to move by an external source such as a pump or a fan. In our daily lives, what are examples of events where thus convection usually happen? 1. Boiling water. When you boil water, heat is transferred from the stove to the water at the bottom of the pot. The heated water rises to the top of the pot and is replaced by cooler water, which then heats up and rises. 2. Heating a room. When you turn on a heater, warm air rises from the heater and circulates throughout the room, while cooler air is drawn to the heater and heated. 3. Cooling a room with a fan. When you turn on a fan, it circulates around the room, which helps to cool you down by carrying away heat from your body through convection. And last, ocean currents. Convection currents in the ocean help to distribute heat and nutrients around the world. The warm water from the equator rises and moves towards the poles, while cooler water from the poles sinks and moves towards the equator, creating a global ocean circulation pattern. Isn't that amazing? Now, what are the different types of aerospace systems? How is heat and mass transfer relevant to aerospace systems? There are many different types of aerospace systems, including aircrafts, rockets, satellites, and missiles. But how is heat and mass transfer relevant to these aerospace systems? 1. Thermal management. Aerospace systems often generate large amounts of heat during operation, and this heat must be managed to prevent damage to components and ensure optimal performance. Heat transfer by conduction, convection, and radiation is important for designing thermal management systems that can dissipate or retain heat as needed. 2. Propulsion. Aerospace systems rely on engines to provide thrust and power. Heat transfer is critical to the design and operation of these engines, which often involve complex combustion processes and high-temperature environments. And last, environmental control. In spacecraft and other aerospace systems, maintaining a suitable environment for human occupants or sensitive equipment is crucial. Heat and mass transfer are important for designing environmental control systems that can regulate temperature, humidity, and air quality. Overall, heat and mass transfer play a critical role in the design and operation of aerospace systems, and engineers must carefully consider these processes in order to ensure the safety, performance, and reliability of these systems. But I want to focus on one aerospace systems, namely hot air balloons. Hot air balloons have been used for recreational and commercial purposes since the 700s. They are often used for sightseeing, aerial photography, and special events such as festivals and races. They are a popular form of aviation because they offer a peaceful and scenic way to travel through the air without the noise and speed of other aircraft. In hot air balloons, it is a type of aircraft that uses the principles of convection to rise and fly through the air, and it plays a crucial role in how the balloon stays aloft. The balloon consists of a large fabric envelope that is filled with hot air using a burner that heats up the air inside. As the burner heats the air inside the balloon, it causes it to become less dense and rise. As the air rises, it creates a convective current that pulls in cooler air from the outside of the balloon. The hotter air then continues to rise, creating a circular flow of air that allows the balloon to afloat and move with the wind. The concept of buoyancy is also essential in convection. Buoyancy is the upward force exerted on an object immersed in a fluid and is directly proportional to the density difference between the object and the fluid. In the case for hot air balloons, the less dense hot air inside the balloon creates an upward buoyant force that lifts the balloon off the ground. In summary, convection is the transfer of heat through the movement of fluids, and it plays a crucial role in how hot air balloons stay aloft. The convective currents created by the temperature difference between the hot air inside the balloon and the cooler air outside allow the balloon to rise and float, demonstrating the power of convection in heat transfer. All of that was interesting, right? Well, that's to be expected, as heat and mass transfer is all around us. We just need to be aware and informed about it to actually see it's happening all around us at any time, regardless if it comes from an aerospace system or not. However, I learned 3 key insights which I would love to share with all of you. 1. Importance of thermal management. Aerospace systems often generate large amounts of heat during operation, which can have a significant impact on the performance and safety of the system. Effective thermal management systems are essential for the dissipating or retaining heat as needed to maintain optimal performance and prevent damage to components. And 2, this is not an insight but more of an additional bit that I would like to share with you. But did you know that radiation is another mode of heat transfer that is present in hot air balloons? The burner emits infrared radiation which heats up the surfaces of the envelope and the basket. The rate of radiative heat transfer depends on the temperature and emissivity of the surfaces, as well as the distance between them. But I think that will have to be a different video for another time. Lastly are the environmental considerations. Aerospace systems operate in a variety of environments, including the Earth's atmosphere, space, and other planets. Heat and mass transfer are important for designing systems that can withstand the extreme temperatures, pressures, and other environmental conditions encountered in these environments. Overall, heat and mass transfer play a critical role in the design and operation of aerospace systems, and engineers must carefully consider these processes to ensure the safety, performance, and reliability of these systems. I think that's all for me. I hope you guys had a very informative and fun time with me. Make good choices. Goodbye!